Let ABC be an acute triangle with circumcircle omega and orthocenter H. Suppose the tangent to the circumcircle of triangle HBC at H intersects omega at points x and y with HA equals 3, HX equals 2, and HY equals 6. The area of triangle ABC can be written as m root n, where m and n are positive integers, and n is not divisible by the square of any prime. Find m plus n. I uploaded a YouTube video yesterday discussing one possible solution to this problem. Today I found a new solution. It's an alternate solution that I'm going to discuss in this YouTube video. And while yesterday's solution was more power of a point and symmetry based, today's one is more trig based. So first off, notice that the circumcircle of triangle HBC, the first thing you should notice is that's just the reflection of the circumcircle of ABC over BC. So if we consider BC to be horizontal, then we can just move this circle, the circumcircle of HBC, up, and it'll coincide with the circumcircle of ABC. Then the tangent to the circumcircle of HBC at H, since we moved it up, H will get moved to point A, and the tangent at H to the circumcircle of HBC will become the tangent at A to the circumcircle of ABC. So let's draw that in. This is the tangent to the circumcircle of ABC at A. It's parallel to XY, which was the tangent to the circumcircle of HBC at H. So we know that XY is parallel to the tangent at A. That implies AX is equal to AY. And this should be fairly obvious, but if it's not, I'll explain why. Triangle AXY, the reason it's isosceles is because this angle over here, by alternate interior angles, since the two lines are parallel, that's going to equal this angle here. It's also a tangent that cuts off arc AX. And arc AX is also subtended by angle AYX. So in the end, those two angles are equal, and triangle AXY is isosceles, with AX equals AY. Now you might be wondering, what's the length of that AX equals AY? Well, to find out, we're given AH is equal to 3, and now's the perfect time to use Stewart's theorem on triangle AXY. Assume AX and AY are equal to C. Then we can use Stewart's theorem of man plus dad equals bomb plus sink, 2 times 6 times 8 plus 3 times 8 times 3 equals C times 2 times C, that's 2C squared, plus C times 6 times C, that's 6C squared. So 8C squared is equal to 2 times 6 times 8, which is 48 times 2, 96. And 3 times 3 times 8 is 72. So 168 is equal to 8C squared. C squared is equal to 21. So we can update this with C equals root 21. Now we want to find the area of triangle ABC. And to do that, we need both the length of the A altitude and we need the length of BC. And then we can just multiply those two numbers and divide by 2, and we get the area of triangle ABC. But first, let's focus on finding BC. The A altitude is pretty easy. So to find BC, we know it might have something to do with the circumradius of triangles AXY and ABC. So let's find the circumradius of those triangles. They have the same circumradius because they're both inscribed in the same circle omega. And it's pretty easy to find the circumradius of triangle AXY given its side lengths, root 21, and 8. We could either use ABC over 4R is equal to the area of triangle AXY, or we could find cosine A using the law of cosines, then find sine A and use the extended law of sines. I think the second one would be a little faster. So let's do that. We have the cosine of angle XAY is equal to root 21 squared, 21, plus root 21 squared, minus xy squared, which is 8 squared or 64, over 2 times root 21 times root 21. And that's 2 times 21, which is 42. So this is equal to 42 minus 64, negative 22 over 2 times 21. So negative 22 over 42, which is negative 11 over 21. And from this we can find sine angle XAY. It's equal to the square root of 1 minus negative 11 over 21 squared. And that's 121 over 441. This is equal to 441 minus 121 over 441. So it's the square root of 320 over 441. And that's equal to 8 root 5 over 21. So we found the sine of angle XAY. Now we can use the extended law of sines to find the circumradius of triangle AXY. By the extended law of sines, XY over sine XAY is equal to 2R. So XY over 2 sine XAY is equal to the radius of the circumcircle of triangle AXY and ABC. But we know XY is 8. So let's update XY with 8. And 2 sine angle XAY is 16 root 5 over 21. And this is equal to the radius. It's equal to 8 times 21 over 16 root 5. That's just 168 over 16 root 5, which if you divide both numerator and denominator by 8, you're going to get 21 over 2 root 5. So the circumradius of triangles AXY and ABC are equal to 21 over 2 root 5. That is the radius of omega. So what can we do next to find BC or anything that will move us forward in finding the area of triangle ABC? Well, we know AH, and that's equal to 3. And it turns out AH can be easily expressed in terms of the circumradius and cosine A. So recall that AH is equal to 3, which is 2R cosine A. And this can be proved very easily by using the law of sines on triangle AHB. So first, angle ABH, by completing the altitude from BH to AC, it forms a right triangle here, and one of the angles of this right triangle is A, so the other one will be pi over 2 minus A. And the angle at AHB, well, to find that, we need to know the angle at A, which is angle BAH. And similarly to the angle at B, that's just pi over 2 minus B. So this angle over here is pi over 2 minus B. And if you add those up, you get pi minus A minus B. So to sum to pi, which is what the angles in a triangle sum to, the angle at H, AHB, needs to be equal to A plus B, which is nothing but pi minus C. So using the law of sines on this triangle, in triangle AHB, AH over sine of pi over 2 minus A is equal to AB over sine pi minus C. But sine pi minus C is just sine C. And we know AB over sine C is equal to 2R. And AH over sine pi over 2 minus A, well, sine pi over 2 minus A is just cosine A. So AH over cosine A is equal to 2R. And we have proved that AH is equal to 2R cosine A. Now we can use this. Because we know R is equal to 21 over 2 root 5, 2R cosine A, which is 3, that's just going to equal 21 over root 5 times cosine A. So if 21 over root 5 times cosine A is equal to 3, we get that cosine A is just root 5 over 7. That's very important. But to find BC, we need sine A, not cosine A. But we can get that from cosine A. it gives us sine A is equal to, well, sine squared A would be 1 minus cosine squared A, and that's 1 minus 5 over 49, which is 44 over 49. So sine A is the square root of 44 over 49, which is just 2 root 11 over 7. And BC is 2r sine A. 2r is 21 over root 5. And sine A is 2 root 11 over 7. And this gives us 21 over 7 is equal to 3. So it's just 6 root 11 over 5. So we found BC. We need the A altitude now. The A altitude, well, that's not tough to find. If you just note that the reflection of H over BC lies on omega. Now, why is that the case? I forgot to prove this in my previous video, but the reflection of H over BC, it lies on omega for a very specific reason, because angle BHC is equal to pi minus A. We saw that angle AHB was pi minus C, so similarly, angle BHC would be pi minus A. And since it's a reflection, we also have that the angle at B, the reflection, and C, this is also pi minus A. And since it's located on the other side of BC as A, and the angle is pi minus A, that point is concyclic with points A, B, and C. So it lies on the circumcircle of ABC. And by power of a point at point H, we note that 2 times 6 is equal to 12, which is also equal to 3 times the distance from H to its reflection. So the distance from H to its reflection is 12 over 3, and that's equal to 4. It's bisected by BC, so both of these are equal to 2. And the A altitude is just equal to 5. And we know that BC is equal to 6 times the square root of 11 over 5. So the area of triangle ABC is 1/2 times A altitude times 6 root 11 over 5. This is equal to 1/2 times 5 times 6 is 1/2 of 30, and that's 15. The square root of 11 over 5. And this is equal to 3 root 55. It can be written as m root n, where m and n are positive integers, and n is not divisible by the square of any prime. We can confirm that 55 isn't divisible by the square of any prime. It's 5 times 11. Find m plus n, which is just 3 plus 55, or 58. And we have solved an AIME problem 15 in 2 different ways. Thank you all for watching this YouTube video. For more videos before the AIME 1 on February 1, please follow my channel so we can get to 400 followers before then.